Ellipses. In this chapter we're going to talk about ellipses, and we're only going to talk about in this chapter about ellipses whose center is the origin. In another video we're going to talk about ellipses with different origin. Now, what do we know about an ellipse? An ellipse is the set of all points P in a plane, the sum of whose distances from two fixed points f1 and f2 is constant. These two fixed points are called the foci, and the midpoint of the segment connecting the foci is the center of the ellipse. Keep in mind, in this chapter we're going to talk about an ellipse whose center is the origin. So the major axis, the minor axis, and we have the vertices. Now this is the standard form of the equation of an ellipse. When a squared greater than b squared in the first case, we have a horizontal ellipse, and the major axis is horizontal with a length of 2a. Now when the quantity under y squared is greater than the quantity under b squared, so also a squared is greater than b squared, but notice where is the location of a squared in this case. So we get a vertical ellipse, and the major axis is vertical with length of 2a. In both cases, c squared equal to a squared minus b squared. So c is the coordinate of the focus. Now let's practice the equation of an ellipse in standard form. So if I look at my case, I notice the major axis is horizontal. So my a squared is 4 and my b squared is 1, and always in this case, a squared is located under x squared. Therefore, the equation is x squared over 4 plus y squared over 1 equal to 1. Now the major axis is vertical, so my a squared is also 4 but it's under y squared, and my b squared is 1 and it's under x squared. Therefore the equation will be x squared over 1 plus y squared over 4 equal to 1. So that's a vertical ellipse. Another example, the major axis is horizontal, so my a squared is 16 and it's under x squared, and my b squared is 4 and it's under y squared. Now this one, the major axis is vertical, therefore my a squared is 16 and it's located under y squared, and my b squared is 4 and it's located under x squared. Now the intercepts, anytime I need the x-intercept, I need to set y equal to 0 and solve for x, and anytime I need the y-intercept, I need x equal to 0 and solve for y. So the x-intercept are plus or minus a, and the y-intercept is plus or minus b. So let's start with graphing the first ellipse, and is centered at the origin. So keep in mind, in this chapter we're talking about ellipses centered at the origin. So we have graph and locate the foci of x squared over 9 plus y squared over 4 equal to 1. My a squared here is 9 and my b squared is 4, and we have a squared greater than b squared, and a squared is located under x squared, so we have a horizontal ellipse. And let's see the coordinates of my a plus or minus a, and the coordinates of plus or minus b, and the coordinates of the foci. So 3, 0 and negative 3, 0, these are my a and plus or minus a, and 2 and minus 2, these are my plus or minus b. Now for the foci, we know that c squared equal a squared minus b squared. Therefore the foci are, and the foci here is on the x-axis because we have a horizontal ellipse, because the quantity under x squared is greater than the quantity under y squared, so we have a horizontal ellipse. So my A is going to be on the x-axis and my foci is going to be on the x-axis. In other words, my vertices are going to be on the x-axis and my foci is going to be on the x-axis. Another example, I notice the quantity under x squared is greater than the quantity under y squared. Therefore, my a squared greater than b squared. Therefore, here we have a horizontal, another horizontal ellipse. Therefore, my vertices and foci are going to be on the x-axis. So the coordinates of the vertices plus or minus a are going to be on the x-axis, and also my foci are going to be on the x-axis. So let's see the coordinates of a and the coordinates of b. So see, my vertices has plus or minus 6, and we have b plus or minus 3, and now we have the foci. So we get the foci by using c squared equal a squared minus b squared, and that's 36 minus 9, that's 27. So the square root of 27 was 5.196. So keep in mind, the foci is square root of plus or minus square root of 27. We have another example. We need to graph and locate the foci of 25x squared plus 16y squared equal 400. First of all, we're going to divide each term by 400. Therefore, we get x squared over 16 plus y squared over 25 equal 1. Notice 25 under y squared is greater than 16 under x squared, so that's a vertical ellipse. So my vertices and foci are going to be on the y-axis. And c squared equal 25 minus 16 equal 9. So these are the coordinates of the foci. So this is my ellipse with the foci. Now also, let's review where are the coordinates, where are the vertices. So the vertices are going to be on the y-axis. So this is the graph of my ellipse. Another example, we need to graph and locate the foci of 16x squared plus 9y squared equal 144. Therefore, we're going to divide by 144 each term. So we're going to get x squared over 9 plus y squared over 16 equal 1. Still, 16 under y squared is greater than 9 under x squared, so that's a vertical ellipse. So my vertices and foci are going to be on the y-axis. So always we get the coordinates of the foci by subtracting a squared minus b squared. So this is my ellipse. So keep in mind the vertices and the foci are going to be on the y-axis. So these are the coordinates of the foci: square root of 5, 0 square root of 5, and 0 square root of negative 5. Now let's review where is my a and b. Now we need to find the equation of an ellipse from its foci and vertices. Find the standard form of the equation of an ellipse with foci -1, 0 and 1, 0 and vertices -2, 0 and 2, 0. First of all, the foci are located on the x-axis, so the major axis is horizontal. And the center of the ellipse is midway between the foci located at 0, 0. Therefore, the form of the equation is x squared over 4 plus y squared over b squared equal 1. But we know that c squared equal a squared minus b squared. Therefore, b squared equal 3. Therefore, the equation will become x squared over 4 plus y squared over 3 equal 1. Another example, we need to find the equation of an ellipse from its foci and vertices. So we have the foci 0, -4, 0, 4, and the vertices 0, -7, and 7. The foci are located on the y-axis, therefore the major axis is vertical. The center of the ellipse is the midway between the foci located at 0, 0. Therefore, the form of the equation is x squared over b squared plus y squared over 49 equal 1. But we know that b squared equal a squared minus c squared. Therefore, a squared, b squared equal 33. Therefore, the equation will become x squared over 33 plus y squared over 49 equal 1. Now we have the last example, application on an ellipse. A semi-elliptical archway over a one-way road has a height of 10 feet and a width of 40 feet. Your truck has a width of 10 feet and a height of 9 feet. Will your truck clear the opening of the archway? Now, because your truck width is 10 feet, we need to determine the clearance, so we must find the height of the archway 5 feet from the center. If that height is 9 feet or less, the truck will not clear the opening. So, first of all, the equation is x squared over 20 squared plus y squared over 10 squared equal 1. So that's the equation of the ellipse we have. Now we know that x squared is 25. Therefore, after solving for y is 9.68. Therefore, the height of the archway 5 feet from the center is approximately 9.68 feet. Because your truck height is 9 feet, there is enough room for the truck to clear the archway.